Welcome to the garage. I'm Robert, and this is Haslip Cycle Works. We have a special video for you today. We have a collaboration video, the first for Haslip Cycle Works, and for my good friend's channel, Jason at CodeMakesItGo. I'll put a link to his channel in my description. Good friend of mine, known him since high school, and I'm not going to give away my age by telling you when that was, but just know it's been a long time. Here at Haslip Cycle Works, we strive to do everything we can ourselves, but we know our limitations. So when I had this idea for a rotary weld positioner, I knew I could handle the fabrication side of it and the mechanical side. There were some features that I wanted to add to the unit that required some electronics and some programming and things of that nature, which I'm not all that comfortable with or proficient with. So that's when I called in Jason. If you watch his channel, you know that's what he's all about. He loves that stuff. Once he gets here, we'll do a little introduction so you can meet him. And like I said before, there will be a link to his channel in the description, so you can go check out what he's all about. He's got a couple really cool videos going on, doing some really amazing things. The best part is, just like here, if you follow along in his videos, you can recreate what he does at home. We're not trying to keep the information real close to the vest or anything. We want to share with you guys and show you that anyone can do this stuff. It just requires some motivation and a little bit of time. Let me explain the rotary positioner real quick. So, didn't really have a need for it, but I had seen it on a few other channels that I watch on the regular. And a couple of them have mechanical fourth axis CNC attachments hooked to a cordless drill. Seems to work fine for them. Not very consistent though, and pretty rudimentary. Sometimes that's all you need, so I'm not throwing shade on any of those. But I wanted something a little more controllable, a little more repeatable. So if I had 10, 15, 20, 50 parts that I needed to do, all exactly the same, I wanted to be able to set up a controller of some sort and put in my parameters. And once I strike that arc and I get that puddle going, I hit a button or press a pedal or whatever, and we'll show you. I press that button or hit that pedal and the part begins to rotate, and all I have to do is do my part and either feed filler into it, or if it's a fusion weld, just let it go and watch the puddle. And the only thing I really have to worry about is my foot pedal control to make sure that puddle stays the way it should, and we just burn those parts in. So Jason took that and ran with it, and this rotary positioner has so many cool features. And the price point to build your own, well, it is slightly more complicated than some of them out there. It does have features that I haven't really seen on any one particular unit. And some of the store-bought or online ones are so expensive. So that drove me to build the one that I wanted. I mean, that's what we're all about here. If you can't find the one you want, no one makes the part that you need. By God, you do it yourself. So that's what we did. Thing looks awesome, and hopefully we'll get her fired up and she'll go without a hitch. Further ado, we'll get Jason in here, we'll do an introduction, and we'll get this thing rolling.
Hey, I'm Jason with CodeMakesItGo. I'm at Haslip Cycle Works with Rob, and we are here to test the rotary weld positioner that I made him.
I'm going to go over some of the features on this controller that Jason from CodeMakesItGo has built into this controller for us. the beauty of this is it's not a turn it on and adjust the speed sort of deal. This is next level. Yes, we can turn it on and it can run at a certain speed that we determine, but we can also, and I'll have Jason go through the menu here, we can adjust a built-in pause. So Jason, if you want to demonstrate that, we can change the pause, and it goes in 250 millisecond increments. So what it'll do is it'll turn, pause for the amount of time that we determine here, and then step again. Because this is next level and we've really put some thought into this, and Jason is a programming genius. Let's see how it gets better.
You made it
a little too much. Whoa, rewind.
Yeah, back up.
Okay. So because this is a next level setup and we've really put some thought into this, not only can we put pauses in, but we can change the amount of rotation via step after the pause. So we could get an arc going, have it rotate, pause, and then rotate a set number of steps based on the menu that we select here. And nice touch with the Haslip CycleWorks, that's cool. Of course, RPM is RPM, and it goes from
0.1 RPM up to 10.
Up to 10. Here's a 0.1 RPM rotation, and this does have a foot pedal, a little bit smaller than the TIG pedal, but it does have a foot pedal. So when we tap that, whatever we set on the controller initializes, and we hit it again to stop it. And so if you have multiple parts and you have the same weld parameters, you could load up a part, program the controller, start your arc, tap the foot pedal, and let it run, weld the part out. And if you've got 20 or 30 of these parts, you don't have to change anything on the controller between part loads. Like I said, guys, next level stuff here. We've gone from 0.1 RPM to 1 round per minute. And you can see that's probably more about the speed that we're going to look for to actually weld this together. And now we're up to what, Jason? 2 RPM. That's probably a nice, comfortable pace right there. The stepper motor does make some noise. That's to be expected. And we're up to what now?
This is
5 RPM. Give her the full 21 gigawatts. 7 RPM. 8. 9. That's 10. So we're maxed out at 10. That is cooking. You're going to have to be running pretty hot to keep up with that. So this thing's got a nice range on it. We should be able to do pretty much any parameter we would be looking for. Another cool feature is once we have this set up and we know it's going to work, even if we shut this off and turn it back on, it saves our last settings. So if you're welding up a bunch of parts and you lose power, there's no fear if you didn't write down your settings that were on the controller last, because they're going to be stored in memory on this guy. We're going to play around with the control a little bit and get our settings dialed in and get my amperage and gas flow and everything dialed in for the stainless that we're using as a test. And we'll light an arc off once we have it all set up and film that for you guys so you can see it in action. Alright, so what we're going to do first is we're going to establish an arc, and once we see the puddle, then I'm going to hit the go pedal that's attached to the controller from CodeMakesItGo, and we'll see how this goes. Fingers crossed. Oh. If you notice a few things have changed. I have ditched the attached torch setup. The issue wasn't with the rotating positioner or with the welder or the entire setup at all. The issue was when I tacked those sample pieces together. I made the tacks too big. Once I got the piece into the positioner and started rotating it, everything looked good until the tungsten came close to that tack. And of course, when you dip your tungsten into the puddle, or if you make contact with the base metal, it's never good. So that, and when I tacked them up, I didn't measure to make sure all the washers were centered, and I just eyeballed it. So what happened was, as it's welding, not only did the tungsten hit the tack, but the actual piece was out of center. So as it would come by, the torch could be sitting here and the piece would come by and just tap the tungsten. So that made things a little more interesting. This way I can hold the torch as the piece rotates, and if I need to adjust in or out any, I can. I don't think that's going to happen with this setup. There's no stacking here. We're just going to weld this little trench that's between this lag bolt and this washer. Both are stainless steel. Both have been prepped and cleaned with acetone, and I've tacked them and made sure the tacks didn't stick up past the base material very far. And yes, these samples are different than the ones previously in the video, because somebody, not going to mention any names, Robert, forgot that when we were welding and setting everything up yesterday, and this is the next day, by the way, after setting up everything and trying to run it, we got everything situated, everything looked good. We decided to go inside and get some water and talk about, the points of the machine we were going to discuss. And came back out here and got everything ready to go, and foot pedal for the TIG machine, and the arc was completely unstable. I was burning up tungstens. I was burning up the stainless steel. And then it finally dawned on me. When we went in for a break, I turned the gas off on the welder, and when we came back, I neglected to turn it on. Don't! Yeah. So, once we figured out what was going on, Jason had to go. So, this is the next day. I'm going to carry on without him and try to get some good shots of the arc and this thing rotating, and hopefully I can get the speed set up correctly and get this welded and show you guys just how well it works, and hopefully we can get Jason back here to close up the video and kind of summarize for you guys. So I'm going to go ahead and get my hood on and make sure to turn the gas on the welder this time, and get my gloves on, and we're going to go ahead and weld this together. So I'm going to post up two videos for you to compare. The one on the left is going to be a fusion only weld on stainless steel hardware, and the one on the right is going to be a filler added weld on stainless steel hardware. And they're going to be rotating so that you can see the difference. I've buffed both welds back with just a wire wheel. I don't want the colors of the stainless steel to dazzle you and distract you from what we're actually focused on here, which is the weld. I'm not sure if you can see it on the camera or not, but neither in the left or the right can you really make out any distinguishable ripples. Filler was added to the one on the right, not on the left, because I was able to turn the speed up, and my dabs were so quick and the heat was turned up on the torch the ripples didn't show up. If you do see them in the video, you may have to pause it to see them. But even with the naked eye, it's hard to see. But great results. This is the first prototype of the positioner. We will be trying to add some features and maybe tweaking a few things here and there. But let me know down in the comments what you think of it, and if there's anything that you think we should add, or give us some ideas, some feedback on it. And anything that you put in the comment section below, I'll make sure I send on to Jason over at CodeMakesItGo. But as you can tell, it works. So in closing, Jason, would you like to go over the features of the controller again?
Yeah, check this out. Let me show you something. Some of the features here are using the foot pedal. We could turn it on and back off with just the foot pedal, which is pretty handy. As you can see, we're using the 250 millisecond pause. We increase that all the way up to 5 seconds and watch it turn very slowly and pause. And we could also change the steps. So the number of steps that you want to take per pause. That comes in pretty handy. But we could also set the gear ratio. We can set the micro steps, and that has to correlate with your stepper controller. So whatever this is set to, you have to set this to so they match. The pause we just went over, the rotation steps we went over. The speed, RPM is important. That's why you have the gear ratio and the steps. We have the counterclockwise. We turn it to clockwise or counterclockwise, either direction you want it to go. I'm not sure if that really matters. Inversion, and it's the Haslip CycleWorks 2018. That's it. When you push menu again, everything's saved. So when you turn it back on, you see the steps are saved, or pause is saved, and it always starts in paused mode, which is important. So you always have to push the pedal to get going again. And if you want, you could hold in the menu button for 5 seconds. And everything gets reset. So now we're back to gear 1.0 to 1, and we have to readjust everything back up. But that's one way to clear all your memory if you want to go back to factory settings.
And your gear ratio is determined by the pulley ratio between the stepper motor and the gear head, right?
That's right. Yep.
Okay. Cool.
And that's it.
Well, thank you, Jason, for bringing that out and letting me try it. And what I'll do for my viewers is go ahead and I'll get some more practice on this. As I start building parts on this, you'll see it in the channel on the bikes. And eventually, what I would like to do for you guys is, once I hit a certain number of subscribers, let's say the landmark of 1,000, do a giveaway package where once I hit 1,000 subs, we'll build another one of these weld positioners along with a few other items and give them away. So again, just want a special thanks to Jason from CodeMakesItGo. Glad he made this imaginary thing that I had in my head come to life, and we're gonna put it to some serious use. And if you guys have any feedback on it, anything that you think we should add, or maybe a feature that you think is stupid, go ahead and let us know, and maybe it'll be a version 2.0. Who knows? But like I said, we're gonna put some work in on it, and I'm gonna get a little more proficient. And be sure to check out my Instagram page for photos of the welds done on this rotator, and our Facebook page, and of course YouTube. Any parts that I make on this that are featured on the bikes, I'll definitely point that out to you guys. Remember guys, until next time, get up, get out there, and do it.